What if I told you there's a secret tunnel through space and time, one that could let us reach distant galaxies in minutes instead of millions of years? Imagine traveling across the universe through a cosmic shortcut. Today, we're diving deep into one of physics' most mind-bending concepts, wormholes. These aren't just science fiction fantasies from movies like Interstellar, they're actually rooted in Einstein's equations. And the craziest part, scientists might be closer to creating them than you think. The universe is unimaginably vast. Our closest galactic neighbor, Andromeda, sits 5 million light years away. Even if we built the fastest spacecraft imaginable, it would take billions of years to reach it. But what if there was another way? What if space itself could be folded like a piece of paper, creating a bridge between two distant points? This is where Einstein's genius comes in. Back in 1915, he published his famous field equations, a set of mathematical formulas that completely changed how we understand space and time. These equations showed that space isn't just an empty void, it's more like a fabric that can bend and warp. Think of placing a heavy bowling ball on a trampoline. The weight creates a dip, bending the surface. Similarly, massive objects like stars and planets bend the fabric of space-time around them. But here's where things get interesting. When scientists solved Einstein's equations, they found something unexpected. The math didn't just predict black holes, it also suggested the existence of what we now call wormholes. Technically known as Einstein-Rosen bridges, these theoretical tunnels through space-time could connect two distant points in the universe. To understand how wormholes work, let's do a simple experiment. Take a piece of paper and draw 2 points far apart. Normally, to get from one point to another, you'd have to travel across the paper's surface. But what if you folded the paper, bringing those points close together? Now you could punch a hole through both points, creating a direct shortcut. This is essentially what a wormhole does, except instead of folding paper in 3 dimensions, it folds space-time in 4 dimensions. The implications are staggering. A wormhole could theoretically let us bypass the cosmic speed limit, the speed of light. Instead of taking 5 million years to reach Andromeda, we could potentially get there in weeks or months. It would be like finding a secret tunnel through the universe. But if wormholes are possible, why haven't we found one yet? The challenge lies in their creation. To form a wormhole, you need an enormous amount of gravitational force, the kind you'd find in a black hole. But there's a catch. If you use a black hole to create a wormhole, anything that enters would be torn apart by the immense gravitational forces. This is where white holes come in. Predicted by the same equations that gave us black holes, white holes are their theoretical opposite. While nothing can escape a black hole, nothing can enter a white hole, it only spits things out. Some scientists believe that a stable wormhole would need both, a black hole entrance and a white hole exit. The real breakthrough came in 2015 when scientists created something remarkable, a magnetic wormhole in a laboratory. Using special materials and liquid nitrogen, they managed to separate the poles of a magnet and create an invisible tunnel for magnetic fields. While this isn't the same as a space-time wormhole, it proves that wormhole-like structures are possible. But even if we could create a traversable wormhole, there's another mind-bending possibility: time travel. Because wormholes are shortcuts through space-time, not just space, they could theoretically connect different points in time. This raises all sorts of paradoxes and questions about causality that scientists are still grappling with. Scientists haven't given up on faster than light travel, though. Another fascinating possibility is the Alcubierre drive, proposed in 1994. Instead of punching through space-time, this theoretical spacecraft would create a bubble of warped space, contracting space in front and expanding it behind. The ship itself wouldn't break the speed of light, but the space around it would move like a surfer riding a wave. The quest to understand wormholes continues to push the boundaries of physics. While we may not be building interstellar shortcuts anytime soon, the math suggests they're possible. And in science, what's possible theoretically often becomes possible practically. It's just a matter of time and innovation. We're living in an age where science fiction is increasingly becoming science fact. From quantum computers to artificial intelligence, the impossible is becoming possible. Perhaps one day, we'll look back at wormholes the same way we now look at airplanes, as another barrier humanity managed to overcome. If you found this journey through space-time fascinating, hit subscribe and check out our video on quantum entanglement, another mind-bending phenomenon that Einstein called spooky action at a distance.